And we're live! And this is the TWIS Minion Science Island Hangout with the two livest TWIS minions on the planet. Myself and Ulysses. How you doing, Ulysses?
Very good.
A year and a day older.
Oh.
Had your big birthday. And now you got home for your job and you got to celebrate it with your wife. Well, that must have been it.
Had my favorite type of food, Cuban, for dinner.
Okay.
Can you see my lower thirds? All right.
Yes, it can. Everything looks cool. So we're going to start. We got a bunch of stories, very interesting stories as usual. A couple of space stories. We're talking about Ganymede and Ganymede's club sandwich.
That's an awesome story.
Yeah, yes it is. Yes it is. Amazing. And how NASA's new craft, it's going to be America's first space lifeboat in 40 years.
Interesting.
Kind of important if you're going to be in space. And we got one. We're going to struggle with this one, Ulysses, I think.
Yeah.
I threw it in. It's important, but it's really very confusing. Talking about the universe emerging from the dark age and talking about re-ionization of hydrogens and all kinds of wonderful stuff.
Fascinating stuff.
Yeah. Maybe we'll get to a question about privacy. Maybe we will, maybe we won't. In health, there's some really big stories about stem cells. Stem cells regenerating heart muscle in primates could be big. That one, they claim it's something that could be in human trials in, I think, 4 years.
Good.
And stem cells, yeah, definitely. Only 4 more years.
4 more years.
So hang in there.
If I can hang in.
Anything, blood stem cells being reprogrammed into stem cells. This one's in mice. And we've got an important, interesting story about finding the origins of Huntington disease, and a story about neurons that control limb movement, cartilage born in the lab, and some interesting stories about the fascinating subject of poo if we get around to it.
Poo.
Yes.
Really?
Yeah. Just to jump a little bit, what I find fascinating is...
Let's not bury the lead here. Let's talk about some poo.
Okay. Well, I don't know.
In the chat, I didn't get to look at that one. Could you repost that one?
Okay. Well, it's actually our friends in Japan.
I'm fascinated by this, seeing that as, you know, you don't notice it when you're walking around, and maybe you'll grow your little garden out in a little yard of yours, but poo is everywhere.
The interesting thing to me is that we Americans tend to have a thing about antiseptics and cleanliness and stuff, and you know, and when we read about other countries where they don't have toilet paper.
Yeah.
It's a bowl of water in your left hand, and they say, "Ooh, how terrible." Parents deal with poo all the time.
Parents do.
Come on.
Yeah, apparently one of our own, Pamela's dealing with some poo right now.
Yeah. What's the big deal? I don't know.
It's kind of smelly. You can get E. coli out of it. It's not. You don't really want it in your mouth, but you know there's some bacteria that they can re-stimulate your gut bacteria with if you happen to take large doses of antibiotics.
Oh, you don't eat the stuff.
No.
I would say if you got a cut in your hand, you don't want to be dealing with it.
No, you don't want to be dealing with it, especially strangers.
Nurses in hospitals deal with it all the time on a regular basis. People who work in healthcare facilities with the elderly.
And then right from work Porta-John people have to deal with it all the time. And
many people deal with it all the time.
Pump guys, I feel bad for. Not my kind of line of work. I mean, highly underpaid. Highly underpaid.
And I remember Pamela talking about when she was pregnant her sense of smell really increased, and she asked the question, "You people, don't you wipe your butts? Don't you clean your butts?" and I mean, my story leads into, okay, we'll talk about, well, it's Japan, and nobody does a better job of dealing with the bathroom environment than the Japanese.
Really?
And I see the world as kind of split up. You have a part of the world that washes their butt. You have a part of the world, first world, with toilet paper that wipes their butt. And then, you know, I think a lot of Japanese tend to really do both to make sure the job's done properly. Yeah. I thought about it using science and logic, because washing makes a lot of sense. I mean, is wiping really going to get it clean? Maybe just spread it around. I don't know.
You're just going to get the chunks off. You're not getting the bacteria out. You're just getting the chunks out. So wiping, I mean, a bowl of water in your left hand can actually do a better job, as long as it's clean. The key is clean water, and of course you got to wash your hands and that sort of stuff. But the thing is, I thought about it, but one, I'd have to use at least 2 bowls of water, because I'm not, you know, one, you got to have the clean water, and then you got to make sure, I don't know. So it would be a waste of water in our particular case. Yes.
So I will show you. We'll talk about, and you'll have to see this to get an idea of what we're talking about in each one of these stories. I'll screen share and put show notes. Put in the show notes.
Now, I have seen one of these green toilets where it has a sink on top of it, and you wash your hands just like a normal sink, you know, soap and water, and it goes into the holding tank of your toilet. So when you flush your toilet, you're actually using that water twice, which is good.
Mm-hmm. Yeah. Yeah.
I mean, that's just one thing I've seen lately. So we're getting there slowly on the conservation of water. It's one thing. We don't have bidets in this country very much. I mean, you've got to have some money to have that installed.
Yeah.
You want a warm water bidet as opposed to a cold water bidet.
I know there. I mean, there is a toilet, and it might be from Japan. Very sophisticated, but it costs like $1,000 or something. I mean, it's
a little pricey on the average homeowners.
Now you've been on construction sites, so you've dealt with porta potties.
Porta-johns.
Porta-johns. In Japan, they're not messing around with little porta-johns. This is the house of toilet. This is real sophisticated stuff.
It's got solar panels.
Yeah, it's made with polycarbonate sheeting and burnt wood siding.
Burnt wood, what's that?
The angular scheme looks like a modernist exercise in randomness, but the design is actually divided into 6 sections, each of which is cut at an angled fashion. The design is conceived as an architectural compass, which each of these cuts aligning to a major urban center on each continent, except, of course, from Antarctica. What is it? What is it? Stonehenge?
Yeah,
maybe that's what Stonehenge is.
It's a little overkill.
Yes. Just a little bit.
Overkill.
There you go. You can see how it's set up here. Beautiful looking little area. You have the top of it. I think it's for collecting water. The cuts have been carefully calculated to line with the sun during the solstice and during 3 traditional ceremonies local to the island. There you go. Just like Stonehenge. At that time, a ray of light passes through the building. And it's a trick you highlight to the identity of some Japanese god or something. Or something like that.
So it's an intriguing way to elevate the mundane typology of the public restroom to something more, almost cosmic.
Yes.
While placing these picturesque and distinct localities in But see, this is not productive for a job site. You
Oh
have to
no,
be able
oh
to,
no. This is something that maybe, what's the guy with Google might set up somewhere on his.
high-tech. It is a high-tech bathroom, but it's not made for construction workers.
Well,
It's made for everybody else walking around.
it says it's got a prominent oculus opening in the ceiling
I
that
saw
not only lets in light but also harvests rainwater for the proper functioning of the 6 toilets. There you go.
Reuses rainwater, which is good.
So, okay, that's a neat design idea, but, very impractical. Of course, the Japanese, and I'm going on to the next one, a little bit older story, but the Japanese love their computers, the robotics and computer technology. And so what they also have is a Bluetooth-controlled bidet toilet.
That's what I'm talking about.
This is bidet toilets are common, and this company called Lexel has introduced the SATIS, status, I guess, or something like that, where you control all of the features from your smartphone. Only your bottom touches the toilet. You control the wash, the warm air, and dry, all from your phone. So you not only do you get to wash your butt, but you get warm air to come in and dry it.
I think this is taking laziness to a whole new level.
It has a sound system, and it's also you also monitor electricity and water use, and you have a toilet diary.
I tell you what.
Videograms, so you can document your droppings. Whoa, that's a.
I'll give you a sheet of paper and a pencil and a regular toilet, and you won't burn electricity. This is crazy.
And another great invention they have in Japan. And this is a little bit older story, and I wonder if they actually built it. There you go.
Yes, I read that.
Biogas spike. Have you read about this before?
It's disturbing that they're using the gas of your poop to power this. I would think you need a lot of poop, but apparently not.
Jani is here, just in time to hear us talking
Our
about
poop talk, Jani. This is the poop talk.
Got off the screen share. You can tell us. Would you buy a poop mobile, a motorcycle, where instead of a seat you've got a toilet? So when you take a dump, the gas itself can be used to power your car, to power your motorcycle. I don't know.
What do you think, Jani?
That's not so good. So.
Well, in Japan, Japan's a fascinating country, and they really are very obsessed with cleanliness. I mean, to the point, I think, of obsession, where they're talking about, they're designing these high-tech toilets where you can control the water flow, and you got music coming in, God knows what else. And when you go to, and they're into, you wash yourself first, and then you go into the warm bath to relax, which once again to me is you're wasting water.
Yeah.
Well, they're an island country. Maybe they got plenty of water. I don't know.
No, well, I mean, they get rainwater.
And if you go to a public bathhouse, and I'm talking 1965, okay, you go in and you have to shower off, which makes sense. But you don't just shower off. You got these scrub brushes, and you got to scrub. I mean, and since I'm a foreigner, you're the foreigner, they're looking at you at the corner of the eye to make sure you're following the right ritual. So you got to scrub your skin till it's practically red. And then you go and repeat yourself. You got to remember to take 2 showers before you actually get into the bath water.
So you're using a already used scrub brush, right?
I don't know.
Because I wouldn't imagine they give you a brand new scrub brush every time.
It was, as I recall, it was there. I didn't buy one or anything, and I don't remember giving one.
Whatever,
Maybe he did.
Whatever germs are on that scrub brush, you're just putting back on you.
They must have given me one because that's something they think about a lot.
Is this over in Japan?
This is in Japan.
And you were in there in 65?
65, yes.
Wow.
I went there as part of the McNamara Scholarship.
Oh, good.
Got drafted. But it's Japan's a great country. I mean, I don't know how much it's changed. Obviously, it's changed.
Oh yeah,
But
you've changed a whole lot.
But they have some very interesting customs, and that's one of them. Jani, I know you've got a sauna. Are people supposed to take a shower and clean off very, very thoroughly before they go into the sauna?
Sauna?
After they have.
I guess you could take a shower before sauna. But the sauna's going to open your pores up, right, Jani?
Yeah.
Yeah. Then you go take a shower. Or jump in the ice cold water. One of the two.
Yeah.
Yes. That would be the cool part. You know, you take your sauna and you run outside, particularly if it's winter, and you jump in the water and you freeze to
What
death.
you really do is...
Something. Snow.
Snow. Okay.
So what you really should do is go in the sauna, let it open your pores, scrub down, then jump in the snow, and then your pores will close, and you'll get all that dirt out before dirt goes back in. Right, Jani?
Yeah.
Yeah.
I think the Swedes might, but do you guys whip yourself with the birch twigs or something?
Some people do.
What is that? What's that tail that curls around? They make absinthe from. What's that stuff called? Anyway, you can whip yourself with that.
That I could very definitely get into.
I don't want to whip myself. I'm sorry.
All right.
It should be help your blood flow in your skin.
I couldn't understand what you said, Jani. Maybe it's the drag on the system.
No, that's okay. And we should have a shout out to our friend Patrick Picararo, who's off in Bhutan. He's now vacationing in that beautiful Himalayan country, happiest country on the planet, the only country that has a gross happiness indicator, measurement thing. So I hope you're safe and hope you're enjoying beautiful Bhutan.
Yes.
Bhutan?
Don't offend anybody. Get you back in one piece.
Keep smiling. Everybody smiles, I'm sure.
Yeah.
I'm sure he's taking a bazillion pictures.
Don't go to where they'll cut your hands off.
No violence in Bhutan, I'm sure.
Oh, good.
I don't know. All right. I'm going to jump into let's get to the space stories. And this is a neat one. And this is talking about Jupiter's Ganymede moon, Jupiter's moon Ganymede, and how they think it may be layered kind of like a club sandwich.
Mm-hmm.
That's the analogy they made. I'll put up the screen share.
I think this is interesting. Just for the sake alone, the word Ganymede. I love that name. That's a beautiful name.
It's one I can actually pronounce. Now that's close for me. Yeah, well, it's the largest moon in our solar system, and it's a companion to Jupiter. Might have ice and oceans stacked up in several layers like a club sandwich, according to NASA-funded research. Previously, the moon was thought to harbor a thick ocean sandwiched between just two layers of ice, one on the top and one on the bottom. However, this new research says Ganymede's oceans might be organized like a Dagwood sandwich. Okay, Ulysses, do you know what a Dagwood sandwich is? Are you old enough?
I'm old enough because they still run the Blondie cartoons.
Okay. You're a hard-working man, so I'm sure you like the 14 layers. You ever go to the? I can't think of the name of the place. And it's like 14 layers of cheese and meat and God, it's like a month's worth of food for me.
No.
And I don't know how people can eat it in one gulp practically. In any event, and that's where the Dagwood sandwich from the Blondie cartoon. That's where they get the name, and it provides new theoretical evidence for the team's club sandwich model, first proposed last year. The results support the idea that primitive life might possibly have arisen on this icy moon. They say places where water and rock interact are important for the development of life. For instance, it's possible life began on Earth in bubbling vents in our seafloor. Prior to this new study, Ganymede's rocky sea bottom was thought to be coated with ice, not liquid, a problem for the emergence of life. The club sandwich finding suggests otherwise. The good news for Ganymede is its ocean is huge, with enormous pressures, so it was thought that dense ice had formed at the bottom of the ocean. When we added salts to our model, we came up with liquids dense enough to sink to the ocean floor. Let's see, I'll jump ahead a little bit. Previous models of Ganymede's oceans assumed that salt didn't change the properties of liquid very much with pressure. But Vance and his team showed through laboratory experiments how much salt really increases the density of liquids under the extreme conditions inside Ganymede and similar moons. It may seem strange that salt can make ocean denser, but you can see for yourself. You add plain old table salt to a glass of water. Rather than increasing the volume, the liquid sinks and becomes denser. This is because the salt ions attract water molecules. The models got more complicated when the different forms of ice were taken into account. And I didn't even realize there were different ratings for ice. The ice that floats in your drinks is called Ice 1, the least dense form of ice and water. But at high pressure, like those in crushing deep oceans like Ganymede's, the ice crystal structures become more compact. It's a better arrangement, like shoes in your luggage. I don't know. These guys are going off the wall.
Yeah, it's kind of like that. It's where
I don't know.
the atoms have more pressure on them, condensed in a line. So
yeah, that I can see. The ice became
kind of
so
like,
dense.
kind of like formation of coal. You know, you're compressing all that carbon, pushing out all the. Anyway,
Okay.
not coal, but similar.
Yeah, this dense ice, they say it's so dense, it's heavier than water and falls to the bottom of the sea, and they call it Ice 6. So we've got at least 6 different ratings for different kinds of ice. And they threw this model into their little computers, and they came up with an ocean sandwich between up to 3 ice layers, in addition to the rocky seafloor. Lightest ice on top, the saltiest liquid is heavy enough to sink to the bottom, and the results demonstrate a possibly bizarre phenomena that causes the oceans to snow upwards. As the oceans churn and the cold plumes snake around, ice in the upper ocean layer called ice 3 could form seawater. When the ice forms, salt precipitates out, the heavier layer going down and the lighter layer going up. They don't know how long this has existed.
Well,
but they think it could be, you know, maybe that's what we'll find on other planets.
we won't know until we go visit.
I'm definitely up for a visit to Ganymede.
If
Definitely.
we have the money.
Well, that's always the minor.
Yeah,
That's the minor.
and robot transmission.
Yes, yes. I mean, we've got those salt caves and salt caravans. And the other interesting thing, too, is when they talk about the possibility of life, and you apply it to exoplanets, but some super-Earths, and Ganymede is one of 5 moons in our solar system thought to support vast oceans beneath icy crust. So I mean, if you have that possibility, a reasonable possibility of life on 5 moons in our own solar system.
Possibility. I'm wondering if Europa has a bigger ocean below it than Ganymede.
Well, Ganymede is the, it says it's the largest moon.
It's the largest world, but might not have the most water.
Yeah.
I think Europa has more water than Earth does, right?
No clue.
Well,
What was the one in Space Odyssey? Was that Europa, I think?
Jupiter.
It wasn't Jupiter.
The
The movie 2001.
2001, where they go to Jupiter, but maybe it is.
Yeah, but they went and
You're
and
thinking
the Earth, the Star Child. The Star Child created a second sun for us to use.
Oh,
He said, "Don't go to." I thought it was Europa.
y'all can colonate any planet except for the 3rd planet from Jupiter or whatever. Yeah.
Yeah.
All I know is there's a horror sci-fi film called Europa, which is cool.
That's interesting, though. I mean, like, to have all those different layers, you know, like an onion. I mean, heck, you could. The key to me would be you've got to have a dynamic interactions happening. If you have dynamic interactions happening on a planet, a moon, an asteroid, I think you'd have the possibility. That really dramatically increases the possibility for life. If you've got a static planet where nothing is changing, well, you can't have evolution. Nothing is changing. So I would say
you have to have some form of energy, like I'm sure Jupiter's tugs and poles and everything. Maybe that's where the energy's coming from. To keep the water liquid, because I'm sure its core is probably not liquid anymore. So I don't know.
Well, I mean, we have life forms living in the ice. In
The microscopic life forms,
Yeah.
but we've had plenty of heat to evolve complex, life forms here on this planet. It'll be interesting to see if you need that much energy to evolve other forms of life, farther out. That would change our whole concept of habitable zones.
Oh yeah, man. I mean, if we could just
What little we know.
find some form of microbial life, someplace like Mars, moons, maybe even asteroids. We know that, haven't they found evidence of bacterial life on asteroids?
We know that some things, if sheltered well enough, will survive re-entry. In fact, like viruses, there's what is it called? There's something that can survive re-entry that the Planetary Society was testing with, but a mission kind of failed. I don't know. It was
Well, I mean, you put in a capsule. I mean, something like
kind
a
of
water
over.
bear can stay dehydrated for
Yeah, maybe it's water
a
bear,
long time.
tardigrades, or whatever.
So I'm sure there's organisms that can do it. That's where I mean, I gotta believe until we find it, we can't say it's positive. But man, the odds got to be so much in favor of life. If you have chemical interactions, right? You mentioned interactions, chemistry. Yeah. As long as you have chemistry happening, you know, why wouldn't life eventually form out of that chemistry? I don't know.
As long as you have enough energy, anything's possible.
Oh yeah.
Energy in the right.
I'd say in this case, it's got to be probable, not possible.
Yeah, right chemical combinations and energy to do it with.
Okay. Well, let's take a look at NASA's new Lifeboat.
Oh, I've got an addendum to this. They said somebody asked Charles Bolden today, and he had to go face Capitol Hill. What would happen if the Soviets didn't want to work with us anymore? And they said that would be the end of the space station as we know it. So, well, there you have it, folks. We're totally dependent upon the Soviets because we didn't think anything through. Not that we knew the Soviets were going to start invading countries when the shells were retired, but I even asked him this question. I was like, what happens if something happens and the Soviets don't want to? Oh, that'll never happen. Ask Charles Bolden. He goes, no, we ain't got to worry about that. We have great rapport with the Russians.
I think the scientists, absolutely. The scientists, your astronauts, they get along just beautiful.
There, sat there and told me to my face that that'll never happen. I mean,
well, can't say that.
He must be a politician, Charles Bolden, a public servant.
I don't know that.
He's a veteran shuttle astronaut. I don't know. Maybe they couldn't have seen this coming, but they don't have money, and they're up on the hill complaining that we don't have independent services. And he's saying, well, we have defunded commercialization to the point where it takes forever to launch a rocket. So they need to fund NASA at higher levels, so maybe Elon Musk or Orbital or the proposed Orbital at Terry, or they're trying to merge, you know, so we can have more commercial traffic surface low Earth orbit. So we just don't have enough money. Who knows? All right.
Well, that commercial partnership.
Perhaps in the first.
Yeah. I think that the collaborations with industry in the long run are the way to go. And you can never know when something's going to happen when you have a group of countries. European Space Agency, for instance. You have a group of countries trying to collaborate. You're always going to have that problem with politics getting in the way. But for the most part, that's, I think, going to be short term. And right now, we're drifting into politics, but you just got two guys, Obama and Putin, and you know they're just arguing over who's got the bigger one. You know, I think.
I don't know about that. I think the Russians have a little bit more motivation because they don't have a warm water port.
Oh, that I understand. They have one now.
They have one now, and why stop there?
Well, I mean, because it doesn't make
it. We're not going to militarily oppose them. That would be insane. And they know this. So one side's going to blink and the other one won't. They'll keep going.
Now, that, my humble opinion, because, I mean, I can understand what happened when they had to take that port. That was a national security issue for Russia. And now what you have in the Ukraine is a developing civil war. You have the ethnic Ukrainians and you have the ethnic Russians. And they don't like each other so much. Or at least there are some activists that don't like each other so much. It's almost inevitable.
They could be plants. Don't get me wrong. It could be plants. I mean, they were renting from part of they had their own the Russians had their own place. They were renting it like we did. We established a base. And now they were giving Ukrainians cheap oil, and now they don't have to do that no more. So, I mean, they just got a free port out of it instead of renting it like they were.
Well, they were going to get that port, no matter. I'm sure. I am absolutely certain. Whatever else would have happened, they were going to have control of the port. And since that port city in the area is, I believe, mostly ethnic Russian, it's inevitable that it would be part of Russia.
For them to take it.
And don't forget, it was the prior president. I mean, they needed money, so he could have gone to the West for money. Instead, he went to Russia and got what, a $17 billion loan.
You have to remember, this prior president was part of a plot to assassinate his political rivals. He poisoned his political rival, almost killed him, and he's got ties with Russia. So he's not really a legitimate president. He was more of a pawn, and he was getting kickbacks if you've seen his palace. So I mean, it's no surprise that Russia has a certain stake in the Ukraine.
Well, you know, we can get this right back to our story of cooperation.
Cooperation.
What do you have? You look at what's called Ukraine. You have this artificial map drawn, when in fact what you have is two communities: ethnic Russians, ethnic Ukrainians. I mean, it's almost inevitable that the ethnic in a country that's unstable, in a country with a lot of problems, it's inevitable that the ethnic Russians are going to say, we want to control our own state, our own area. I think that's inevitable. The only fight was going to come where you have ethnic Ukrainians and ethnic Russians sharing a city, and where it's the ethnic Russians in the minority, and they still want to take control.
If you look
that's where you're going to have
president, you have to look at the history of this country. Ukraine was its own independent area before World War II. It was only after World War II that when the Soviet Union started occupying the Eastern Bloc that they put their people there, because most of the Ukrainians were slaughtered by the Nazis and by the Soviet Red Army. So technically, it was their land. They just didn't have the population to receive it. But so half of it's Russian.
Well, not half of it. It's just some areas. But don't forget, you look at Estonia. You look at Estonia, Lithuania, and Latvia. All of these countries have significant Russian ethnic populations. In those three countries, there's no talk about the ethnic Russians those countries becoming part of Russia. I mean, I've read several stories in Estonia where the Russians living there are quite happy. Hey, they don't want to be part of Russia. So you can get, once you get that cooperation, and once you get the ethnic Russian, any two ethnic groups, the more they live separate lives away from each other, you got problems. The more they cooperate together, the better it is, and we're back to science. Bringing us back to science. Cooperation and lifeboats. So, here's
I don't know. If as long as we have the space station, we'll need a lifeboat to exit it.
I think we should be encouraging cooperation with Russia, China, and every other country in the world. And where we have, for instance, what's happening in the Ukraine, nothing to do with the United States, nothing to do with China. So, oh, you can have things like, oh, we don't like what you're doing, so we're going to put economic sanctions on you, something like that. There's no reason why you can't still have cooperation, which is essential when you're talking about space.
Well, we don't want our money going to Russia, which they're not going to send us up there for free.
Well, here's a couple of interesting points here about this lifeboat. Something I hadn't realized is the number of people on the space station at any time is dictated by by the lifeboats that are available. In this case, they're Soyuz rockets, Soyuz spacecrafts.
We have to train to use their stuff. We don't.
Right. That's the idea. We want to have our own.
We'll be familiar with it. This is pretty cool. It says it has the ability. It's got several criteria, and I'm sure it's going to cost us billions of dollars, but it has to remain functional for 210 days.
Mm-hmm.
It has to support a crew for 24 hours as a shelter. If you have to leave, it can be a quick evacuation instead of, like they do now, where they click down the sheets to click off activities. I like this part: ability to withstand small impacts from micrometeors.
Mm-hmm.
And
that's why you need it built out of the right material, because it also can't be too heavy.
It's got to be strong, which probably be a little heavy. It's got to return 4 crew members to Earth, which means it's going to be bigger than Apollo.
Mm-hmm.
That can only hold 3. So you're looking at the Orion capsule.
I guess they've teamed up in this case with Boeing and something called Boeing, SpaceX, and the Sierra Nevada Corporation.
Yeah.
There you go, that collaboration again. And really, as the story pointed out, you're not going to be able to do any kind of space exploration unless you got these lifeboats.
Yeah.
So it's pretty essential. Okay, Ulysses, are you ready to wander off into the complicated, dark world of dark energy and physics?
You're asking the wrong. You're asking the wrong guy. I mean, it's interesting.
It's interesting. I'm going to give it a shot. 2 things will be happening. 1, we may actually learn a few things, or we're going to be completely confused.
I'm going to be completely confused.
I don't know which is it. Which it's going to be.
It's going to hurt one way or the other. It can be embarrassing at the same time.
All right, what are we talking about?
The re-ionization of the primordial universe.
Yes, the spectrum of gamma ray burst afterglow indicates the beginning of the re-ionization process. Okay, this team of people, a whole bunch of people, University of Tokyo, using the faint object camera mounted on the Subaru telescope, car company.
Yes.
They studied visible wavelength spectrum of the afterglow of a gamma ray burst, violent explosion of a massive star. The direct measurement of the absorption features in the spectrum of the afterglow. Ulysses, could you check the question and answer area? I forgot to. Anybody asking us questions?
Well, keep going.
Okay. Revealed the proportion of neutral hydrogen gas absorbing the light in its vicinity. The finding provides the best estimate of the amount of such neutral gas in the early universe. Means that scientists can now narrow down the time when the universe was beginning to re-ionize after its dark age. Now we got a paragraph coming up. Man, if we can get through this paragraph, we're doing great. I probably won't even bother going into the rest of the story. If we can get through this paragraph. Okay. Hydrogen is the main element of ordinary matter, 5% of the universe, which is primarily composed of more abundant dark matter, 27%, and dominant dark energy, 68%. During a stage of high temperature, right after the universe's birth, 8 and 14 billion years ago, the hydrogen atom was ionized, split into a nucleon and electron. When the temperatures dropped about 400,000 years after the universe's birth, the nucleon and the electron combined to make neutral hydrogen atoms. At that time, the universe became transparent to radiation, and light-emitting objects became visible. In the present universe, most hydrogen exists as diffused, ionized, intergalactic gas. To account for this difference between the past and the present, there must have been a transitional era of re-ionization after the dark age of the universe. And this transitional period was filled with neutral gas. They don't know yet when this transition occurred, or they don't understand the process by which it took place. One possibility is that ultraviolet radiation from the first generation galaxies in the billion-year-old universe ionized the hydrogen gas. Therefore, it is very important to identify when re-ionization occurred. Okay, let's back up. We're talking about ionization. Now, ions are, as I understand it, an ion is an atom that has a disproportionate number of electrons and protons. A neutral atom has the same number of electrons and protons. Now, something that has confused me is if you have an imbalance, if you've got more electrons in the atom or more protons in the atom, what's keeping that atom together? And maybe, is this something that can only exist for a short period of time?
If you have the same or different number?
You got two kinds of, in terms of...
You've got two different kinds. You have an ion, which is an imbalanced atom, or just your regular atom.
Which has the, because that's the thing. What holds the electrons inside an atom is that the atom itself is neutral. It's magnetically neutral, has a neutral charge. And that means you've got the same number of electrons, and the electrons are trying to push away from each other.
But, I mean, the neutrons are neutral, but the protons inside the atom are not. So they kind of bond the electrons with...
Right, that's the other half of electromagnetism.
Yeah.
You've got the negatively charged electrons being pushed away from the positively charged protons. No, attracted to. I'm sorry, they're attracted to the protons. At the same time, you have the electrons themselves pushing away from each other, and this counterbalances. So you've got a balance. So your atom is held together. But then I read about ions. Ions that have an imbalance. And I don't understand what's keeping these atoms together. If you have more electrons, which are negatively charged, and fewer protons, you know, what's keeping those electrons together in the atom itself?
Well, ions will try and bond as quickly as you can. Like acid's got a lot of ions in it, so it's going to transfer. You know how it chemically plates itself. You know, with the copper and the zinc, so it's going to try and transfer ions until they're all stable and it gives off no more current. from what I understand. Now, the strength of the atom is so powerful. That's why you have a nuclear explosion, because it takes a lot to break that proton and neutron bond apart. So it's pretty strong. It's an atomic force.
Oh yeah, that's the weak interaction overcoming the strong interaction.
Yeah, you know, I mean, it's amazing. It's also chemistry, which I didn't do too well in. So, I mean, this is where you'll need Dale.
No, yeah, we're stuck here. I don't know. We don't have Patrick. We don't have Christopher Morrison. We don't have Dale.
We can't get Justin no more.
Well, maybe if Justin pops in by some chance, we can ask him that question. But that's one of the things where when you talk about something being ionized, now you know more about chemistry than I do. So when you ionize something, you're dealing with these atoms, that have an imbalance. They've got more electrons than they do protons, and so what's happening then is maybe these excess electrons, or you can even have excess protons, but maybe these excess electrons.
Yep, a loss of.
You're losing them.
Mm-hmm.
When you want to create that ionization process, how do you do that?
How do you create an ion? You have to throw in.
If you can remember.
I think you have to throw in another electron into one of its orbit clouds, overpack its orbital cloud, and it'll try and attempt to bond with something.
Hmm.
See what Wikipedia is for. Everybody look up Wikipedia and look up ion.
Well, I can see
look it up now. Hopefully.
Well, we're talking about the early universe.
Yes.
Okay. And initially you have something like a plasma, and you've got very, very diffused energy. I don't even know at what point you would have. It takes a while for this plasma to cool down, and then you can begin to have matter forming, is my picture. My picture of that early universe is you have this diffused plasma, and everything is moving away from each other, let's say. And it's only, and this is, I'm guessing, I'm trying to make a guess here, it's only when the temperature, as it says, 400,000 years ago, the temperature cooled down, that these diffused, ionized atoms began to combine to make neutral hydrogen atoms. And that is the kind of thing that led to all of the kind of matter. That's electromagnetism in action, which led to all the different types of matter gradually coming together, that little push-pull, gradually resulting in quarks coming together to form protons, and electrons coming, and protons and neutrons coming together to form nuclei, and then electrons getting into the mix. How's that sound?
Yeah.
Okay.
I've got the Wikipedia up here.
Okay.
This is an ion is an atom, basically what you said. Is an atom or molecule with the total number of electrons is not equal to the total number of protons, giving that atom a net positive or negative electrical charge. Ions can be created both chemically and physical means. In chemical terms, if a neutral atom loses one or more electrons, it'll have a positive charge, known as a caton. And if the atom gains an electron, it's a negative charge, known as an anon. Anon. Am I saying that right? A-N-I-O-N.
Okay.
An ion consists of a single atom or atomic. An ion consisting of a single atom or an atomic monoatomic ion. If it consists of two or more atoms, it is a molecule or polymeric polyatomic ion. Sorry.
Well, one of the things you mentioned, I'm looking at this last sentence. Very important to identify when re-ionization occurred relative to the formation of the first generation of light-emitting objects. Light's photons. And photons are part of that electromagnetism. So where you have an interaction where electrons are
photons are way smaller than electrons.
Okay.
So how would they? I'm confused.
Okay.
We picked up where you were stopped reading. I was looking at that. Oh, here it is. At the time, the universe became transparent to radiation, and the light-emitting objects became visible. In the present universe, most hydrogen exists as diffused, ionized intergalactic clouds.
Now, right there, if we stop right there, what we're talking about is light.
Mm-hmm.
So perhaps these ionized hydrogen atoms are not giving off photons, they're not giving off light, and you can't see them. So it's only when re-ionization occurs that you get this dynamic interaction where you have light-emitting objects, where you have photons being given off somehow,
usually
so that you can see objects.
Usually in the core of a star.
Mm-hmm.
Right.
Okay.
Did we confuse? Did I add to the confusion?
I think maybe we should kind of stop there. I don't think well, let's go on to some much better.
Well, if Richard shows up, he's the guy to talk to, because he knows he's our astronomy guy.
The thing is, I know the idea is you're talking about this early plasma where everything is diffused, and then something occurs that gets these particles of matter, the basic particles of matter in the standard model, the quarks, electrons, the hadrons, etc. All of these fundamental particles starting to come together through electromagnetism, and electromagnetism begins to exert its force. So you're talking about diffused energy forming into some kind of coalesced energy, whatever. Going on. This is something I think we can understand. And this is health. We have a couple of very good, very positive stories about stem cell therapy, which could really help us in the near future, hopefully. The first one, and this is, that's a Newsbeat, I forget the organization, maybe Harvard? University of Washington. Okay, this is the University of Washington, and they regenerated heart muscles in primates to help repair damaged hearts.
Nice. I want that.
And their approach suggests, and let's see how, they have successfully restored damaged heart muscles of monkeys using heart cells created from human embryonic stem cells. They've got a headline here, which I don't. Human embryonic stem cells derive cardiomyocycles regenerated non-human primate hearts. Okay. Before this study, it was known. Before this study, it was not known if it is possible to produce sufficient numbers of these cells, these stem cells, and successfully use them to remuscularize damaged hearts in large animals. So you need a lot of these blood cells that have become pluripotent, and they can be used to repair damaged heart cell muscles. Okay.
Well, that's good.
He said he expected this approach will be ready for clinical trials in just 4 years.
4 years?
That's what he's saying, 4 years.
Wow.
Got to hang in there just 4 more years.
If you can live 4 more years, maybe we'll have something.
And they experimentally induced controlled myocardial infractions, a form of heart attack, in anesthetized pigtail macaques.
Poor macaques.
Yeah. The infarcts, that's what it says, were created by blocking the coronary artery of macaques for 90 minutes. And that's this established time frame for studies on these poor animals.
That's a long time.
Human myocardial infractions are typically caused by coronary heart disease, coronary artery disease. The resulting lack of adequate blood flow can damage heart muscle and other tissues by depriving them of oxygen. Because the infarcted heart muscle does not grow back, myocardial infraction leaves the heart less able to pump blood and leads to heart failure. Okay. 2 weeks before the experimental myocardial infractions, the Seattle researchers injected a billion heart muscle cells. A billion heart muscle cells derived from human embryonic stem cells. That's a mature process then. Wow. They're able to get a billion heart muscle cells. The name they gave them. Human embryonic stem cell derived cardiomyocytes or something like silicates or something like that into the infracted muscles. 10 times more of these types of cells than they've ever been able to generate before. All of the monkeys have been put on an immune suppressive therapy to prevent rejection of transplanted human cells. And that's something to remember for our next story, because with when you're using embryonic stem cells from a blastocyst that you've created in the lab, that's a foreign cell to your body. So you have to suppress your body's immune system in order for your own body not to try and kill that cell. So an important aspect when they go to perfect this will be how much immune suppressive therapy they need to do. That's going to be key. The researchers found out that over subsequent weeks, the stem cell derived muscle cells infiltrated into the damaged heart tissue, then matured, assembled into muscle fibers, and began to beat in synchrony with the macaque heart. After 3 months, the cells appeared to have fully integrated into the macaque heart muscle. Wow. That's amazing.
That's awesome.
It says on average, the transplanted stem cells regenerated 40% of the damaged heart tissue. Now 40% is better than nothing. And it would certainly help if you've got a damaged heart, if we can make that heart 40% healthier. Let's see, the results show you can now produce the number of cells needed for human therapy and get formation of new heart muscle on a scale that is relevant to improving the function of the human heart. That is amazing.
All the time we live in.
I mean, the process really works so well. In monkeys. That's not mice. This is monkeys. So,
yeah, I know.
It's a bigger animal. And you know, I can see it 4 years. I can definitely see it.
It's a macaque, though. It's not a chimpanzee or an ape. But still,
It's a primate.
it's not a close primate. It's a macaque. I don't know.
I don't know.
Macaques kind of close. I keep
I don't
thinking
know
they're
how
like
closely
lemurs.
related they are, but it's a primate. That's the big thing. And so primate hearts, you can make some guesses that, you know, primate hearts, no matter the species, are going to work somewhat similar. And and if you have a process that works amazingly well with this smaller primate, of course, heart, that really shows you. I mean, that to me shows me a really good potential that this is going to help us. Won't know. And the big problem here is you're talking about the fact you have to deal with the body's immune system. You have to suppress it, and that's always going to be a problem when you're suppressing the immune system, because now, I mean, it works great if you've had a damaged heart, but now you got to take other medication to build up that immune system or take the place of the immune system. Now you're talking about a real complicated process, as you would with heart transplants and any kind of transplants. Now the next story is also talking about the same kind of thing, using stem cell therapy. You little... There we go.
I have the link.
This is our friend Science Daily, and this is the Boston's Children's Hospital. And the researchers have reprogrammed mature blood cells from mice into blood-forming hematopoietic stem cells, HSCs, using a cocktail of 8 genetic switches called transcription factors. Dale, where are you? We need you for this. And that's right off the bat is the key thing. You're talking about, you're taking mature blood cells. You're not taking embryonic stem cells from a blastocyst you create in the lab. You're talking about mature stem cells, probably from a person, and you're turning them into this particular kind of blood cell, these hematopoietic stem cells. The reprogrammed cells, which researchers have dubbed induced HSCs, have the functional hallmarks of HSCs and are able to self-renew and give rise to all of the cellular components of blood like HCSs. And it's a significant step forward in the more sought-after goal of regenerative medicine. The ability to produce HCSs suitable for homeopathic, I don't know, mispronouncing the word, sorry, stem cell transplantation from other types, in particular, more mature or differentiated cells. And that's big, because now if you can do this with mature stem cells, possibly out of your own body, you don't have to go through that immune repressant stage. The HCSs are a basic starting material for something else, HCSTs, regardless of their source. Bone marrow, umbilical cord blood, and peripheral blood. And I know that bone marrow and I know umbilical cord blood is a source of these blood stem cells. And HSCT is tied to the number of HCSs available for transplant. The more cells, the more likely the transplant will hold. HSCs only comprise about 1 in every 20,000 cells in bone marrow. If we can generate autologous HCSs from a patient's own cell, it could be transformative for transplant medicine and our ability to model diseases of blood development. So instead of getting 1 out of 20,000 cells, you're now taking basically any cell, any mature cell in bone marrow, and turning it into the kind of stem cell that you need. Again, all stem cells. They screen gene expression in 40 different types of blood and blood progenitor cells from mice, and we are talking about mice here. From this screen, they identified 36 transcription factors, genes that control other genes that are turned off and on, and are expressed exclusively in HCSs, not in cells that arise from them. Blood cell production invariably goes in one direction, from stem cells to progenitor cells to mature effector cells. And they wanted to reverse the process and derive HCSs from differentiated mature blood cells using transcription factors they found that were specific to HCSs. And they found 6 of the 36 factors, plus 2 additional factors not originally identified in the study. And they were sufficiently robust. They were sufficient to robustly reprogram 2 types of progenitor cells, pre-B cells and common myeloid progenitor cells, into these induced HSCs. They reprogram their cells by exposing them to viruses. There you go. Exposing them to viruses containing the genes of all 8 factors and a molecular switch that turned the factor genes on in the presence of dioxyline. They then transplanted the exposed cell into recipient mice and activated the genes by giving them mice dioxyline. Don't know what that is. That's interesting how they did this. I mean, we think of viruses, nasty viruses. But in this case, you're using viruses to create a particular type of cell that you need. 2-step process. You create these molecular switches, the factors that create these molecular switches, and then you add this chemical dioxyline.
So everything's turning into the Matrix. It's just we've got to find the level of programming and understand the language to all our cells.
Yeah.
Scary.
No, not scary to me. Yeah, it's understanding better how cellular reproduction works. The better we understand that, the better we can use it to do all kinds of wonderful things. It's a slow process. You're right. And you got to be careful when you're talking about stem cells, induced stem cells. They've used induced pluripotent stem cells, though. They've done that before. In the previous study, they did that, and they talked about creating 1 billion blood cells using embryonic stem cells.
Well.
And because this is in mice, of course, this is, we've got a ways to go before we ever reach the human studies. Let's see. The current findings are far from transitional yet to the transplantational clinic. Still to be answered are the precise contributions of each of the 8 factors to the reprogramming process, and whether approaches that do not rely on viruses and transcription factors can have similar results. Now, it's interesting to me that they've used viruses in this process. Are you excited, Ulysses? Are you falling asleep?
Yep, getting close to it.
You want to get back to that birthday cake of yours.
Oh yeah, we had a chocolate flan
Ooh.
type of pastry cake at a Cuban restaurant tonight. It was very good. Had nothing to do with stem cells though.
We've been at this for a while. Do you want to? Can you think you can get through one more study?
Yeah, let's go through. Well, what kind of study are we doing?
We got three. You pick. In one case, we're talking about hunting down the origins of Huntington's disease in the brain.
Okay.
And the other one, we're talking about spinal cord neurons that control skilled limb function. And in the third one, we're talking about creating human cartilage grown on a lab chip.
What? Okay, let's do that one.
Okay.
That would make
Human
no sense.
cartilage. Well, you got your friend, I'm blanking on her name. Your space buddy friend.
Oh, the
Apologies. I can't, geez, my
She
mind.
does need some cartilage, or
That's a problem, cartilage. And she has gone through stem cell therapy, but it didn't create the right kind of cartilage. And here we may be talking about the right kind of cartilage, perhaps.
yes.
Significant step towards reducing the heavy toll of osteoarthritis. They have created the first example of living human cartilage grown in a laboratory chip. And ultimately they want to use this is 3D printing. 3D printing approach to create replacement cartilage for patients with osteoarthritis or soldiers with battlefield injuries or okay, man, this is really bad. What the heck is her name? Because she got hers in roller derby.
It's either some sort of lacrosse or some sort of field hockey or something.
I thought it was roller derby. In any event, osteoarthritis has a severe impact on the quality of life, and there's an urgent need to understand the origin of the disease and develop appropriate and effective treatments. And we hope this particular method will be useful, is basically what he's saying. Estimated that up to 1 in 2 Americans will develop some form of the disease. They said they're artificial cartilage built using a patient's own stem cells. There you go, a patient's own stem cells can offer enormous therapeutic potential. And ideally, we'd like to be able to regenerate this tissue so people can avoid having to get a joint replacement, which is pretty drastic. In addition to offering relief for people with osteoarthritis, this replacement cartilage could also be a game changer for people with debilitating hip joints. I got a friend. She's in the hospital now. Well, she's actually recovering from joint surgery. And of course, it would help soldiers in the battlefield. Creating artificial cartilage requires 3 elements: stem cells, biological factors to make the cells grow into cartilage, and a scaffold to give the tissue its shape. Their 3D approach achieves all 3 by extruding thin layers of stem cells embedded in a solution that retains its shape and provides growth factors. They say we essentially speeded up the development process by giving the cells everything they need while creating a scaffold to give the tissue the exact shape and structure that we want. 3D printing. The ultimate version is to give doctors a tool they can thread through a catheter to print new cartilage right where it's needed in the patient's body. Other researchers have experimented with 3D printing approach, but in this particular case, this method used a significant step forward because it used visible light, while others have required UV light, which can be harmful to living cells. In another significant step, they successfully used 3D printing method to produce the first tissue-on-chip replica of bone cartilage interface, housing 90.
We can't do that. We can't do that physically. So if we can figure out how to way to do that, then it saves so much pain and lives of people.
Yeah.
Because you can't attach it. We don't know how to attach it.
I don't know how long it will take. In this particular case, when we're talking about the cartilage, it was a small amount of cartilage.
Hopefully we can
Right.
Scale it up. I mean, I've hurt my shoulder, torn my car. I mean, it just hurts.
Mm-hmm.
Nothing you do once you rip it off, so it's awesome.
Now we're talking about Star Trek, practically. And
it's so weird. Did somebody from the future write Star Trek? It'll be 100 years from now, so I put it in my story.
That's the rub. That is the rub. It always seems just around the corner.
Just around the corner.
We're almost there. We're almost there. But I can definitely see some big steps. These are big, and each three of these stories we're talking about important steps.
Your body going, and that's what we really need. Stuff that'll keep our body, like our livers are messed up. Well, we can clone you a new liver. We'll put it in there. You won't reject it. And well, my joints are falling apart. Well, we can rebuild your joints. I mean, just awesome stuff.
Yeah, and we've talked about people getting maybe an exoskeleton or something like that, but in this case, you just build your own muscles up, your own.
Yeah, we don't need that unless it's in the Matrix. Got to fight the robots off with the exoskeleton, but other than that, we're fine.
Now the other question, which I'll touch briefly on because it is.
I
don't want to get negative here.
Wait a minute.
Positive.
Yeah, you're the positive one. I'm the negative one.
Yes, Jani.
See what it's coming down to, Ed? It's regeneration, like Doctor Who. It's not anything else. It's not Star Trek. It's Dr. Regeneration. Nanobots will infect us and rebuild us with all this DNA stuff.
Well, I think ultimately, one, you start with analyzing the cells in a growing baby. You get their DNA. And you say, okay, is this baby predisposed to a heart condition? Maybe even you can look at how their arteries are developing or something, and you can see is there some kind of is it the kind of blood cells that will maybe stick to the walls of the arteries? I don't know. But looking at that child, being able to take DNA from the child, a blood sample or something, and saying, okay, here's a diet this child needs when it grows up, so it can avoid.
We're going to get to the point where we can genetically engineer a child.
Oh yeah.
You won't have to. Well, you'll still have to graft stuff, because people break bones all the time, whether you're genetically better or not. But we're going to have technology. It's going to be awesome. It's going to be Gattaca. It's going to be wonderful. We'll go to.
Could be awesome.
We'll evolve species that can take long trips in space.
The big thing to me, you've got to have evolution doesn't work unless there's randomness involved. And what you're talking about, you're trying to remove the randomness.
Yes.
You're trying to say, okay, this is what I want. This is the child I want. I don't want no mutations and randomness to, get into the picture. And that would be a problem, because evolution requires randomness. It's impossible to know when a trait is, which seems to be a bad trait now, turns out to be something absolutely essential in the future. Just think, if you could take a pill and eat anything you want, all the bacon you want, all the chocolate cake you want, no worries about heart disease.
Wait a minute. We have a pill, and if you eat all the junk, it poops you out.
You know, for the most part, we really can do things already.
We can do a lot of
Just
things. We can't bring you back from the dead yet. But we have found out that we can slow down if we can slow down your brain, drop your core temperature a few degrees, chill your brain out, we can slow it from decaying, and if we can get your body back to working, you'll come back to life. We couldn't do that 20 years ago. But like those people on the Titanic, and I saw this from the news, if we had the science like we do now, we could have brought most of those people back because their brains were frozen. We just had to bring their bodies back.
Okay.
Like this was coming from a study in Japan, your favorite country.
Okay.
You know, where these avalanches.
It's amazing what they can do.
Well, they found these frozen hikers, and they thought they were dead, and they did a little CPR, warmed their bodies up, and they came right back.
Oh yeah, that is another thing. We're learning how regenerative our bodies are, much more than what we had suspected.
Yeah, we can preserve if you can put your body in ice for a little bit. Maybe they can resuscitate you, but it's still low. I mean, you only get like 25 people.
You had your accident, and they froze your brain, and now they can take that brain and regenerate it. Do you want your same body?
No, I want George.
Does your wife want you to have the same body?
No, she doesn't want it. Jani wants a robot body.
Okay.
Jani wants a robot body. More like that cartoon thing in Star Wars. And I want it to be George Clooney.
You know, when we start talking about deep space travel, Yanni's right. If we're going to be going off into space, who knows how long, we'll need robot bodies.
Yeah, we'll need robot bodies. How long our brain survives, we'll have to do like that movie that, what's his name's in, where he becomes the computer. They scan his brain and put it in the computer. Johnny Depp movie. What is that?
Yes.
Transcendence. We'll have to become like that if we go.
That's the latest movie that nobody's watching.
Yeah, we'll have to do like that to go to other star systems because it's so far away.
Yeah. Yeah. I
have to.
I don't want to start over.
It's coming. It's coming.
Yeah. Yeah. I would not. Well, let's see. If I have my, what would I want to change? I do not want to dramatically change my life since I am happy. Can't say I'm 100%, but you know what? I've been through a lot of stuff. It has produced me, and I'm happy.
I'm very happy. I would want not to have to go to the bathroom or feel those pains. That's what I don't want to do. I know it'll have to happen, but not as often. and how about that?
It would be, well, I don't know. Well, it would be great to have a metabolism so that you can consume more calories and eat more of the good food you like.
Okay. I'd like not to get fat. That would be nice.
But then, once again, you think about food supply in the world. If you're eating anything you want and as much as you want, there's not enough food left over for anybody else.
Yeah.
I mean, I can see you saving that extra piece of cake for your wife. Don't know you're going to save that extra piece of cake for me.
Yeah. Hard telling. I mean, it's amazing the times we live in.
Yes, it is.
Just nobody pays attention to.
We are. Are you kidding me?
We do.
Very shortly, we're going to have another hangout, another podcast, another show. This Week in Science.
This Week in Science, Will.
In Science Island.
Science Island. Yep. That's where we need Science Island to do the experiments.
Yes.
Show the rest of the world how to live.
I should check our hashtag Science Island. we need to do our own hashtag. So tweet us.
Yeah, you know how hard it is to build a brand. I think of Kirsten trying to build her brand. That is a lot of work.
Right.
It's a lot of work.
Yes.
I mean, I'm not even going to try. But I mean, she's got 50,000 followers. She's got at least 5,000 subscribers, maybe 50,000 subscribers, and only 300 are contributing to Patreon.
Yeah.
That's tough, man.
It is kind of tough.
All right.
Star power alone won't do it. You have to get out there and work. That's what I found. You have to work hard every day.
Yeah. How's your job looking in terms of its longevity?
Pretty good. We're building a northern DC area is awash in construction. They're building stuff so fast. People are always going to need power. And I was watching. I'm going to rant on a little bit. I was watching the news tonight, and they were talking about oil spills and the new oil they're pumping out, and these rail cars keep crashing, and pipelines are leaking. If we could only convince people that have to commute to and from work within a 30 or 40 mile radius, convert them to electrical energy, we could do it. And it wouldn't be that bad. I mean, plug in at night and have solar panels up on all these buildings there. I mean, millions of buildings. I mean, it's rooftops forever. And there's no trees in Northern Virginia. They're if there are, they're not on top of the roof. They're not covering these roofs. You could charge your car at work for free. Have the company pay for it. And there's this look up on YouTube called Solar City. I
heard about it in Tree Hugger today.
Yeah, Christian, my friend from the Wallops launch, he went to Solar City, and they installed solar panels on his house for free, so he just pays them for the electricity he uses. So he doesn't deal with the power companies anymore, and they sell power back to the power companies during the day and sell him power at night off the grid because he's using their power during the day. So it's a pretty interesting. He doesn't have to pay anything but their rate. So he's doing the world a favor by not burning fossil fuels, and they're making money off of him when he has to take power off the grid. So it's a pretty interesting concept.
Does he have to stay on the grid for emergency purposes? Is he able to really just completely remove himself from the grid? Is he that confident?
I don't think that's part of your agreement. See, if you owned your own power cells, if you owned your own solar voltaic cells, you can do whatever you want. But see, it's like a contract. He's kind of renting them.
I can very quickly.
So yeah, let's look up on their website. See what
I was on the website just shortly. There's
And there's another
Article
Elon
about
Musk.
Solar City coming to Nevada.
This is Elon
Taking
Musk.
orders. Solar City. Okay. It is on solarcity.com.
This is an Elon Musk thing. I mean, this guy's a
What is
genius.
it? I don't know what it says.
I
Free
like Elon
quotes.
Musk more and more every day. Suing the government. See, we need more private competition.
Okay, I want home. Give me a free. How much can I save? Well, they make claim pricing options. Okay. Purchasing power. You can purchase a solar system or go solar as far as $0 down and pay as you go. Let's see, pay as you go. They don't give me a dollar quote here. They get back to that free consultation. I wonder if that tree hugger article mentions let's see, Jani gave us a link as well.
What'd you do, Jani?
Solar tiles generating new parking area. That is also a very so much space available, like you said. There's a picture of it. How much money are we talking about? Solar City, $30 a month. It says Solar City can allow Nevada homeowners to go solar for as little as $30 a month?
Depending on how much usage is of that.
Wow. Design, installation, financing, insurance, monitoring, and a performance guaranteed included. They're taking orders from Nevada for as little as $30 a month. Because, I mean, well, I live in a condominium, so I don't have any choice.
Well, yeah, and the good thing is they guarantee your roof wherever they put these panels over. So if your roof fails where they did the installation, they'll pay for it all, which is reasonable.
That's amazing.
Yeah, it's a brilliant concept. You know, it's the Elon Musk concept.
What's going on?
Somebody's going off.
Mine.
Yeah, I mean, there's...
Ja, just TWIS notification.
Police?
TWIS in science.
Oh, okay. You've got it set up so the timer goes off when This Week in Science. There we go. So we will end our little hangout. Covered a lot of interesting stories. I think we did a great job. Minor little hitch with that one story when they started talking about ionizing freaking electromagnetism or something. I don't know. But aside from that, and hopefully, I will be here next week. Hopefully, so will Ulysses and Jani and maybe a few other friends. So see everyone next week.